Functions can be combined. Functions can be added together, subtracted, multiplied, divided, and so on. So, for example, if f of x is x minus 1 squared, and g of x is 1 over x squared plus 1, then I could multiply the two functions together. So f of x times g of x is x minus 1 squared divided by x squared plus 1. I can add them. I could subtract them. I could do things like f of x minus 3g of x. These operations are fairly self-explanatory. So I could do x minus 1 squared minus 3 over x squared plus 1. But functions can also be combined in a different way. They can be composed. So functions can be composed. So if I write down f, a little circle symbol, and then g of x, this denotes putting one function inside of the other function. So this denotes f of g of x. So first you're going to take your number x, apply the function g, and then with that result, you're going to apply the function f. So let's see some examples of this. So why don't we say that f of x is x squared, and let's let g of x be the square root of x. Then I can compose the two functions in two different ways. So I could say that f composed with g of x, that's where I take my function, my number x, first I do g, so I take the square root, and then after that, I apply the function f, which squares the input. So this might look like the function x, and it almost is, but there's a subtle difference. You can only plug in positive or zero numbers for g. So you can't plug in a negative number to g. That's not in the implied domain. You can only plug in numbers 0 or bigger. Therefore, in this composition, you can only plug in numbers x that are 0 or bigger. So it is the function x, but only on the domain of numbers 0 or bigger. If you have a negative number x, can't even do the composition. On the other hand, I could do the composition in the other order. So I could do g composed with f. That would be the square root of x squared, because first I square the number and then I put the result in the square root. As we've seen in a previous video, this simplifies to the absolute value of x, not x, but the absolute value of x. And in this case, the domain is all real numbers. So every number that you like, we could write that down using this interval notation. Why? Because the domain of f is all real numbers, and I'll never get a negative in the square root no matter what I plug in for x. Let's do another example. So let f of x be the function 1 over x. The domain of this function is all numbers that are not 0. Then I can compose a function with itself. So f composed with f of x is equal to 1 over x plugged into 1 over x. If you simplify the fraction, you just get x. So again, this looks like it's the function x, and it almost is, but the domain is all values x that are just not equal to 0. Now, I'll finish this video with an example. If you have x squared plus 1 squared plus 2, then I can actually write this as the composition of two functions. So sometimes if you have things that look like functions inside other functions, that's exactly what they are. So if you look, I'm kind of putting x squared plus 1 into another operation. So this is a composition of g of x equals x squared plus 1. That's what I'm doing first. And then after that, what I'm doing to this output is I am squaring it and adding 2. We can see it's now f composed with g of x. Okay, there's a brief introduction to combining functions and function composition. Excellent.